Hello everyone, welcome to my channel on engineering mathematics. This video is continuation of my previous video on concept overview of random variables. In this video, we will see examples based on probability distribution function of discrete as well as continuous random variable. So let us see our first example. In this example, we are given the probability function of the discrete random variable x in this tabular format and we are asked to find c. Let us first understand this tabular format of the probability function. This table consists of two rows in which in first row we are given values of x. We see x takes values 0, 1, 2, 3, 4, 5, 6 and 7. And in second row we are given the probabilities of values of x. Let's say probability of x is equal to 0 is 0 given. Probability of x is equal to 1 is given c. Probability of x is equal to 2 is given 2c and so on. Now let us see how we can find out the value of unknown c from this table. For that we are going to use the important property of the probability function which says sum of probabilities of all the values of x is always equal to 1. Therefore let us add these values from the second row. We see it is 0 plus c plus 2c plus 2c plus 3c plus c square plus 2c square plus 7c square plus c is equal to 1. When we simplify this LHS, we see it is 10c square plus 9c. This 1 on RHS, I am going to take it to LHS. So we see a quadratic equation in C. When we solve this, I found C takes two values. One is 1 by 10, that is 0.1, and another one is minus 1. Guys, note that C denotes the probability of x is equal to 1, and we know that probability can never be less than 0. Therefore, C is equal to minus 1 is the impossible value. Therefore, we discard it and we consider C is equal to 1 by 10. I hope guys you understood how to find the value of the unknown from the probability function. Now let us extend this question. I am taking the same probability function and I am asking here to find probability of x less than 6 and probability of x between 0 and 5. Let us first understand what is meant by probability of x less than 6. It means sum of the probabilities of values of x that are strictly less than 6. So find what are the values of x that are strictly less than 6. They are 0, 1, 2, 3, 4 and 5. Therefore, we add probabilities of x equal to 0, 1, 2, 3, 4 and 5. They are 0, c, 2c, 2c, 3c and c square. And we just found that c is equal to 1 by 10. So after substituting it, we find p of x less than 6 is equal to 81 by 100, that is 0.81. Now let's find p of x between 0 and 5. So ask yourself, what are the values of x that are between 0 and 5? They are 1, 2, 3 and 4. We add probabilities of 1, 2, 3 and 4. We find it is equal to 4 by 5. Let us see another example. Here I am taking the same distribution table and asking you to find probability of x greater than or is equal to 6. So ask yourself, what are the values of x that are greater than or is equal to 6? They are 6 and 7. So to find p of x greater than or is equal to 6, we simply add probabilities of x equal to 6 and x equal to 7. That is 2c square plus 7c square plus c, where c is 1 by 10. When we add it, we find probability of x greater than or is equal to 6 is 19 by 100, that is 0.19. Let us proceed for next example. Here, keeping the same probability distribution function, I ask you to find the smallest value of k such that probability of x less than or equal to k is always greater than half, where k is positive integer. So let us find such a k for which probability of x less than or is equal to k is greater than half. We'll solve this example using trial and error technique. That means we will substitute values of k one by one and we will check whether p of x less than or is equal to k is greater than half. We begin by substituting k equal to 0. So let's check what is p of x less than or equal to 0. P of x less than or equal to 0 means sum of probabilities of values of x that are less than or equal to 0. There is only one value of x which satisfies this condition, it is 0. And its probability is 0, so p of x less than or equal to 0 is 0. But 0 is not greater than half, so k cannot be 0. Now let us substitute k is equal to 1. So let's check what is p of x less than or equal to 1. For that, let us see what are the values of x that are satisfying this condition. There are only two values of x that are satisfying this condition, they are 0 and 1. Therefore, let's add their probabilities, 0 and c. But c is 1 by 10. So 0 plus c is 1 by 10 and it is strictly less than half. It cannot be greater than half. So k cannot be 1. Now let's put k equal to 2 and check what is p of x less than or equal to 2. For that, check what are the values of x that are less than or equal to 2. They are 0, 1 and 2. So add their probabilities. So add 0, c and 2c. So it is 3c. 3c is 3 into 1 by 10, that is 3 by 10. But 3 by 10 is still less than half. It is not greater than half. So k cannot be equal to 2. Now let's put k equal to 3. So probability of x less than or equal to 3 is c plus 2c plus 2c, which is 5c. 5c means 5 by 10. But 5 by 10 is half. It is not greater than half. Therefore, k once again cannot be equal to 3. Now let's take k equal to 4. When I put k equal to 4, p of x less than or equal to 4 is c plus 2c plus 2c plus 3c. That is 8c. 8c is 8 by 10. That is 4 by 5. And 4 by 5 is greater than half. Therefore, k has to be 4. I hope guys you understood this answer. Now let us proceed for next example. Question is, a discrete random variable x has the following probability distribution. Then we are asked to find value of unknown k, probability of x greater than or equal to 2, and probability of x between minus 2 and 2. Once again, we are given the probability distribution of a discrete random variable x. Because here x takes finite values minus 2, minus 1, 0, 1, 2 and 3. Let us see its solution. First we find value of k using the property of the probability function, which says sum of probabilities of all the values of x is always equal to 1. So let us add probabilities of all the values of x. They are 0.1, k, 0.2, 2k, 0.3 and 3k, and equate it with 1. After simplifying LHS, we get 6k plus 0.6 is equal to 1. This is linear equation in k which can be easily solved, after solving which we see k is equal to 1 by 15. So this first sub question is done. Now we find p of x greater than or equal to 2. So observe what are the values of x that are greater than or equal to 2. They are 2 and 3. So we will simply add probabilities of 2 and 3 to get p of x greater than or equal to 2. So p of x greater than or equal to 2 is p of x equal to 2 plus p of x equal to 3. That is 0.3 plus 3k. But k is 1 by 15. So p of x greater than or is equal to 2 is 1 by 2. Now we find p of x between minus 2 and 2. So check what are the values of x that lies between minus 2 and 2. They are minus 1, 0 and 1. So we simply add probabilities of minus 1, 0 and 1 to get P of x between -2 and 2. Therefore, adding k, 0.2 and 2k, we get P of x between -2 and 2 as 2 by 5. Now let us proceed for next example. This one is interesting. Given that if the probability mass function P of x of a discrete random variable which assumes values x1, x2, x3 is such that P of x1 is 2 times P of x2 and is equal to 3 times P of x3. Then we are asked to find such a probability distribution function of x. So let us proceed for solution. Obviously, x is a discrete random variable because it takes only 3 values x1, x2 and x3. And given that P of x1 equal to 2 times P of x2 is equal to 3 times P of x3. Using this relation, I can say that P of x2 is half P of x1 and P of x3 is 1 by 3 P of x1. Now let us use the property of the probability function, which is sum of probabilities of all the values of x is equal to 1. So here P of x1 plus P of x2 plus P of x3 is equal to 1. Substitute for P of x1, P of x2 and P of x3 as follows. I'll keep P of x1 as it is. I'll write P of x2 as half P of x1 and I'll write P of x3 as 1 by 3 P of x3. And I will write P of x3 as 1 by 3 P of x1. Here P of x1 is common in all terms. Taking it out, we get 1 plus 1 by 2 plus 1 by 3. Further simplifying which, we will get P of x1 as 6 by 11. Now using this value of P of x1, we will find out values of P of x2 and P of x3 using these two relations. So P of x2 is 1 by 2 into P of x1, that is 1 by 2 into 6 by 11, solving which we get P of x2 is equal to 3 by 11. Similarly, P of x3 will be 1 by 3 into 6 by 11, which is 2 by 11. Now let us create the distribution functions table in this way, in which first row will consist of values of x and in second row we will write the corresponding probabilities. So here x1's probability is 6 by 11, x2's probability is 3 by 11 and x3's probability is 2 by 11. I hope guys you understood this solution. Now let us proceed for next example. Here question is, if P of x equal to x is defined as x upon 25, where x is equal to 1, 3, 5, 7 and 9, then we are asked to find probability of x is equal to 1 or 3 and P of x between 4 and 8. Let us proceed for solution. First we create the distribution table for the given random variable x. So in row 1 we write values of x 1, 3, 5, 7, 9 and in row 2 we write the corresponding probabilities. Here definition of probability distribution function says P of x equal to x is x by 25. So if I put x equal to 1 over here, I get P of x is equal to 1 is 1 upon 25. Similarly, if I put x equal to 3 here, I'll get P of x equal to 3 is 3 upon 25 and so on. Now let us proceed for P of x equal to 1 or 3. P of x equal to 1 or 3 means P of x is equal to 1 union x is equal to 3. By addition rule of probability, we can say P of x is equal to 1 union x equal to 3 is P of x equal to 1 plus P of x equal to 3, which is 1 by 25 plus 3 by 25, that is 4 by 25. Similarly, we find P of x between 4 and 8. Note that the values of x lies between 4 and 8 are 5 and 7. So we simply add probabilities of x equal to 5 and x equal to 7. They are 5 by 25 and 7 by 25, which is 12 by 25. I hope you understood this solution. Now let's go for next example. Next example is on continuous random variable. We are asked to find the value of k such that the following will be the PDF. We are also asked to find p of x less than or is equal to 1.5. Here f of x is defined as this. We have to find the value of the unknown k such that f of x will become PDF. According to the definition of PDF, we know f of x can be PDF only if it satisfies two conditions. First says f of x should be greater than or equal to 0, and second says integral of f of x dx over the limit minus infinity to infinity is equal to 1. Now using these two conditions, we will find value of unknown k. So let us take first condition, integral of f of x dx over the limit minus infinity to infinity equal to 1. Since x is varying from 0 to 3 and in that too this interval 0, 3 is split into 3 parts, we will split this integral into 3 parts. First from 0 to 1, then from 1 to 2 and then from 2 to 3 in this way. And in each interval we will substitute corresponding value of f of x. Kx for this interval, k for this interval and k into 3 minus x for third interval. Now we integrate these terms. Integration of kx is kx square by 2. Integration of k is k into x. Integration of k into 3 minus x is k into 3x minus x square by 2. Later we substitute these limits, after which we get k into 3 by 2 plus 3 minus 5 by 2 equal to 1. Further simplification will give us k equal to half. So value of the unknown k appearing in the definition of f of x is 1 by 2. This value of k will make f of x PDF. Next we will find out probability of x less than or equal to 1.5. For that we will integrate f of x dx from minus infinity to 1.5. From minus infinity to 1.5, x is partitioned into two parts, 0 to 1 and 1 to 1.5. So we split this integral into two parts, 0 to 1 and 1 to 1.5. And we substitute the corresponding value of f of x over here and here. In 0, 1, f of x takes value kx, and in 1, 1.5, f of x takes value k. We have already found what is k, so we substitute it over here. Also we integrate x here and 1 here. Integration of x is x square by 2 and integration of 1 is x. After substituting limits, we get p of x less than or equal to 1.5 as half. Guys, you can pause the video and check this calculation. After this, we go for next example, where function f of x is defined as this. We have to show that f of x is PDF and we are asked to find p of x between 2 and 3. Let's go for solution. To show that f of x is PDF, we have to prove that f of x satisfies conditions of PDF. That is, f of x should be greater than or equal to 0 and integral of f of x between minus infinity to infinity limits is equal to 1. Note that f of x takes values either 0 or greater than 0. Therefore, f of x is greater than or equal to 0 in all cases of x. Now let us check second condition. For that we have to integrate f of x dx over the limit minus infinity to infinity. In this interval, f of x has a split definition. From minus infinity to 2, f of x takes value 0. From 4 to infinity, f of x takes value 0. So only one interval left, that is 2 to 4, where f of x is non-zero. F of x takes value 2x plus 3 upon 18 in that interval. So we integrate only in this interval 2, 4. and we take f of x value as 2x plus 3 upon 18. Let us integrate this. 2x by 18 can be written as x by 9. 3 by 18 I am keeping as it is. Integral of x by 9 is x square by 18 and integral of 3 by 18 is 3x by 18. After substituting limits and simplifying, we get integral of this f of x is equal to 1. So f of x satisfies this condition as well. Therefore, we say that f of x is PDF. Now we go to find p of x between 2 and 3. P of x between 2 and 3 is simply integral of f of x between 2 and 3. And in this interval, f of x takes value 2x plus 3 upon 18. Upon integration, we get it is x square by 18 plus 3x by 18, just like here. And after substituting limits, we get p of x between 2 and 3 is 8 upon 18. I hope guys you understood this solution. Now it is your turn to solve some practice examples. These are some practice examples on discrete random variable, and these are practice examples on continuous random variables. Guys, please do write me in comment box whether you were able to solve these examples or not. Also write me how much useful this video is for you. To understand more such concepts in future, please do like, subscribe and share my videos. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.